P6, example number 5. One last thing. What they want us to do is they want us to solve a quadratic equation. And so we have they've given us this quadratic equation. Now I want to show you, we're going to go a little bit above and beyond what the textbook says. This is going to require a complex number. It's going to require a complex number because when we plug this into the quadratic formula, we're going to end up with, you know, that square root thing is. In other words, to solve this, we're going to say x is equal to minus b plus or minus b squared, the square root of b squared minus 4ac all over 2a. Now what's going to happen is this right here, all this stuff underneath the square root, and sometimes we attach a fancy word to that, discriminant, right? Sometimes that's negative. So if it's negative, then I can't take the square root of it, not with real numbers. Now what I want to do is I want to show you, I want you to think about this. When we solve this, what are we really saying? What we're really saying is these are the x values that makes y equal 0, right? So if I can't find a real number that makes y equals 0, what does that mean graphically about this function? Now when y equals 0, what else do we know about the graph? That's where it crosses the x-axis. So if I can't find a real solution, what do we know about the graph? Let's look. So if I come in here and I graph this function, and I say x squared plus x minus 1, and I graph it. Oh, it helps when you copy it out of the book. I thought it was a little weird. I was trying to, that's a +1. What do you notice about my graph? It doesn't cross the 0 axis, or it doesn't cross y equals 0 or the x-axis is what I meant to say, right? So if we're trying to figure out when this thing's going to cross the y or the y-axis or the x-axis when y equals 0, right? We're trying to see when this graph is going to cross this, right? Because when we cross the x-axis, y equals 0, but y is never going to equal 0, so how can I solve it? I can't, not with real numbers, so I'm going to have to use imaginary numbers. Why are we talking about the function so much and the graph? Is because sometimes the graph, if you're taking the ACT and you have multiple choice answers and it has only one complex number, in other words, A is a real number, choice B is a real number, choice C is a real number, and choice D is an imaginary number, and you graph the function and it doesn't cross the x-axis, which of the multiple choice answers is it? D. And you could do it like that. 10 seconds. That's all it will take you. But anyways, let's finish this problem. Based on this, remember when the quadratic equation is written as ax squared plus bx plus c equals 0, that's the only way that the quadratic equation works. It just so happens that the book has given us the quadratic equation written in this form. So that means that a is equal to 1, b is equal to 1, and c is equal to 1. So when I crank through there, x is equal to negative b, which is 1, plus or minus the square root of 1 squared minus 4 times a, which is 1, times c, which is also 1, all over 2 times a, which is 1. That's pretty easy, right? So I'm going to say x is equal to negative 1 plus or minus, this is 1 minus 4, or negative root 3 all over 2. Well, we can't take the square root of negative 3. So what we're really doing is we're going to say negative 1 plus or minus the square root of 3i all over 2. And we could clean that up. In other words, we could say that x is equal to negative 1 over 2 plus root 3 over 2i, or x is equal to negative 1 over 2 minus root 3 over 2i. That's it. Any questions?